Myself, Dr.N.Ram Babu, working as an assistant professor in the Department of Electrical and Electronics Engineering at the University-Surampalem. Today, we are going to discuss about transient responses in series RC circuit with AC excitation in Laplace domain. So, at the end of this session, we are able to gain the knowledge and analyze the transient behavior of electrical RC circuits. Here, we are dealing with Laplace domain equations. So, as we stated that here we are going with series RC circuit, that means the resistance R is compared in series with capacitance, and at time t period equal to 0, the switch is closed and is connected to a supply, where I of t is the series current flowing through the circuit, RC circuit, and VR is the voltage across the resistance, and VC is the voltage across the capacitance. And as we stated that AC transients, the supply voltage E is Vm sin of omega t plus omega t. Here we have considered the phase angle is 0, that means the theta angle is 0. Okay, as it is a RC circuit, that means capacitor here. Capacitor plays a major role for state space equations. So here the capacitor does not allow any sudden changes in voltages. That means Vc of 0 plus is equal to Vc of 0 minus is equal to 0. The inductor does not allow any sudden changes in voltages. So here what we are doing is, here we are applying the KCL equations for the circuit. Therefore, it is given as E is equal to I of t into R plus 1 by C integral of I dt. So if I apply KCL equations for, if I apply the Laplace domain equations, okay, E is Vm sin omega t. So for Vm sin omega t, if I apply Laplace transforms, Vm into omega sin omega means omega by s square plus omega square. That is equal to I of t, it will be I of s into R, and 1 by C integral of I dt, it will be I of s by s. Okay. Now from this expression, I am taking this I of s as common. It will be R plus 1 by sc. Therefore, if I simplify this one further, I am taking I of s common over here. For I of s is equal to Vm into omega by s square plus omega square into 1 by sc plus R. In general, for applying Laplace transform, it should be 1 by s plus a or s minus b, like that it should be. But here it is 1 by sc plus R. Now I am converting this to s plus a or s minus b connotation. It will be Vm by s square plus omega square into 1 plus scr divided by sc, means it will be into sc. Now it should be in the form of 1 plus s plus a or s minus b, that means s should be the common. So from here also I am taking the s term as common. Okay, Vm omega into sc divided by s square plus omega square. If I take this RC common, it will be s plus 1 by RC into RC, because we have taken RC as common. So therefore, this C and this C will be get cancelled. Therefore, we got the solution as Vm omega s by R divided by s square plus omega square into s plus 1 by RC. Okay. Now I am converting into, now I am splitting into partial fractions. See, A divided by s plus j omega plus B divided by s minus j omega and plus C divided by s plus 1 by RC. Okay. So now I have to do the partial fractions method and all the things, and I need to find out the values of A, B, C, and so that I will be substituting it in this expression. Okay. Now I am solving this part. See here, K1, K2, K3 we have written. I am simplifying this one further. This one I am simplifying it. See, K1 into s plus j omega into s minus j omega plus k2 into s plus 1 by rc into s minus j omega plus k3 into s plus 1 by rc into s plus j omega, denominator will be same, and that is equal to Vm omega by r, right? Vm omega into s by r. Okay. If I simplify this one further, but if in order to take out k s square terms as separate and s1 terms as separate and s2 power 0 terms as separate, we are supposed to use variable and separable method. Therefore, k1 into s square plus s into j omega minus s into j omega plus omega square plus k2 s square plus s by rc minus j omega into s minus j omega by rc plus k3 into s square plus s by rc plus s by j omega plus j omega by rc, which is equal to Vm into omega s divided by r. Now, if I take k1 terms constant, okay, and also see here sj omega minus sj omega, it is getting cancelled, and apart from that everything is same. Now, I am taking s square term constant. So, if I am taking s square terms constant, k1 plus k2 plus k3 is equal to 0. Now, if I take s to the power of 1 terms constant, k2 by rc from here minus k2 j omega plus k3 by rc from here plus k3 by j omega is equal to Vm into omega by r. Here s to the power of 1 term is there. See, so here I can get k2 and the expression is in the form of k2 and k3 only, no k1. Okay. Now, similarly, if I take s naught to the power terms constant, s naught terms, see here k1 into omega square, and this one minus k2 into j omega by rc, here it is, and in this expression plus k3 j omega by rc equal to 0. Now, see, this expression I am naming it as 1, and this expression I am naming it as 2, and this expression I am naming it as 3. After substituting, that means after solving all these 3 equations method, and we will be getting the values as in this manner. I have directly substituted those values, and you can see it. Okay, and also moreover we have done the Laplace domain also. Here, with the help of Laplace domain, we have done it and we have substituted it over here. Now, we are going for the phase and that impedance triangle method, like in the previous case. Okay, so here it is RC circuit, right? It will be R, it will be C. That means 1 by omega C will be this side, and this is the phase angle phi, and this is impedance angle Z. Z is equal to R plus XC, which is equal to square root of R square plus 1 by omega C whole square. Okay, if I write this angle of sin phi is equal to R by Z. Okay, that means adjacent. Sorry, this is for cos. Sorry, sin phi is equal to opposite side XC by Z. The value of XC is 1 by omega C. The value of Z is square root of R square plus 1 by omega square C square. And similarly, cos phi is R by Z, which is nothing but R by square root of R square plus 1 by omega square C square. If you see this expression, Here it is in the form of completely omega r into c square. So now what I am doing is I am converting this into 1 by omega c. That means this omega c which is in the upper part, I am keeping it in down part. Now I am simplifying it further. Now I am substituting this after simplifying this one further, I will be substituting this sin phi and cos phi in this term. So now see here how I am doing this part. I of t is equal to minus Vm e power minus t by Rc by omega c plus after substituting the sine and cosine terms in these expressions, we will be getting the answer in the form of sine into cos, that is Vm by square root of r square plus 1 by omega c square into sine of omega t plus theta into e power of minus t by Rc. During this case, we have considered the phase angle theta as 0. For example, if we consider the theta 0 degrees, if we consider the theta, the phase angle difference in the supply voltage, then like in the RL circuit, this phi will be in the form of theta plus phi, and here also phi, theta plus phi. This plus is for leading conditions, whereas for the RL circuit we have kept theta minus phi, that is for lagging conditions. Okay, so the final expression is I of t is equal to Vm by square root of r square plus 1 by omega c whole square sin of omega t plus theta plus phi minus e power of minus t by Rc into sin of theta plus phi. Okay, and this is some constant term. Now let us solve a numerical in this and we will be closing our session. So if we look into this problem, a series RC circuit as shown below experiences sinusoidal voltage G equal to 100 sin t. 100 sin t, that means the value of Vm is 10 and theta is 0 degrees. After closing at t equal to, that means at t equal to 0, the circuit gets closed and the capacitor gets charged from the supply. The capacitor is the initial at relaxed condition, that means V of 0 plus is equal to V of 0 minus is equal to 0. Find the values of the circuit elements. So the values of the circuit elements are R equal to 10, C equal to 10 microfarad. This is 10 ohms and this is 10 microfarad. Here we are supposed to find the expression of current I of t. From the derivation which you have made, this is the final value of the current I of t. Now I am going to substitute all the values in the circuit. Okay, theta is 0 and here R and C is there. So therefore from that we can calculate the value of sin phi. Okay. Phi equal to tan phi. Tan phi is opposite by adjacent. Opposite means xc by r. Xc means 1 by omega c into r. Okay. Omega is nothing but omega is 1. C value is 10 micro. R value is 10. So from this you can get the value of phi. Phi is tan inverse of 1 by 100 micro. Okay. You will be getting the value of phi. Okay. And we know the value of omega. Omega is 1 from the problem and Vm is 10, R is 10 ohms and omega is 1, the value of C is 10 microfarad. So substituting all the values and we will be getting the solution in the form of amps. Okay. Now coming to the summary, we have done a series RC circuit calculations with the help of Laplace domain. Here because of this capacitance, the current leads the voltages. And here the capacitor is the element that is used to store and release the energy. The power factor in the RC circuit is always leading in nature. Here the capacitance and voltage values strongly dependent on frequency. Okay, thank you.